In this problem, to factor out the GCF, there's a couple things that we need to know. First of all is our rules of exponents. If I have a to the m raised to the n power, that is equal to a to the m times n, right? So in this again, when we're looking to factor out the GCF, remember we're looking for the common factors. And most students understand that we have common factors here of x squared plus 4. The problem with this problem is that we also have powers. So if we're going to factor out a term, we have to have the base to be exactly the same as well as the power to be exactly the same. You can't factor out like different powers. They have to have the same base as well as the power. So how do we get the exact same power? Well, that's what comes into this rules of exponents. Now, the only thing that I see that they do have in common is a denominator of 2. Well, that's really, really important because I can rewrite this as a x squared plus 4 raised to the 1/2 power raised to the 3rd power, right? Because using my rules of exponents, I know that if I rewrite a base raised to another power, that's simply just the product. And what is 1/2 times 3? It's 3/2. I can do the exact same thing over here by taking an x squared plus 4 raised to the 1/2 power and multiplying it by 7. Now what I want you to see is they have the exact same expression, which is a base as well as a power. That is going to be a x squared plus 4 raised to the 1/2. Now when we factor that out, we're dividing that out, and what's going to be left over? It's not just going to be these random powers. These powers are there, but what do they represent? They represent the base x squared plus 4 raised to the 3rd power. So when we factor out that x squared plus 4, we're going to be left with a x squared plus 4 raised to the 3rd power, as well as a x squared plus 4 raised to the 7th power.